Okay, as I said, today we're going to look at the way that waves interact. We're also going to talk about the Doppler effect, and then we'll talk about what a standing wave is. I'm going to do that in short 2 videos. In this first little video, I am going to talk about the 4 ways that waves can interact. They can reflect, they can refract, they can diffract, or they can interfere with one another. So let's just work our way through these 4 types of interactions. Okay, the first one here is reflection, and we all understand what reflection is. This is simply when waves are bouncing back off a boundary, whether they hit a wall or they hit a mirror or whatever they do, they simply bounce off. Now, with reflection, there is a law that is always followed, and this is why things appear the way they do in a mirror. Okay, or why sound comes back at you the way it does when it bounces off a canyon wall or so forth. But that is called the law of refraction, and that is simply the angle of the incident ray will always be equal to what is called the reflection ray. Okay, and they will, whatever angle that incident ray strikes the boundary, the reflection wave will bounce off at the same angle. And as I mentioned, this is why when we look into a mirror and the light waves bounce off of that mirror, we look exact copies, and this is why when you raise your right hand in the mirror, it appears that your image is raising its left hand. Okay, and it's because of that law of reflection. Again, as I mentioned, this not only happens with light in a mirror, but it also happens with sound, if you've ever heard an echo, and that is sound waves being reflected. We move on, we run into what is called refraction. Okay, and this occurs when the wave changes its path as it changes from one medium to another medium. As long as there is a differences in the density of the mediums, then the wave will change that. And the reason for that is because the type of medium determines how fast the wave can pass through. And generally speaking, solids are more dense than liquids, and liquids are more dense than fluids or air, Okay, so the result is a change in the speed of the waves. We look at this glass here, we look at the pencil in the glass, you can see that if we look through the water and then look through the top portion of the pencil that's in the air, it appears that the pencil is broken or bent. And that is because the light travels at a different speed as it passes through the water in the bottom part than what it does in the top part passes through the air. Okay, generally the closer the particles are, or the more dense the particles are in the medium, the faster the waves can move. So they can exchange the energy from one particle to another particle because they're closer together. So again, we get a change in the path of the wave as it moves from one medium to another medium. And this can be easily observed here looking at the pencil in the glass of water. Third type is diffraction, and this is simply the bending of waves around the edge of an object. Okay. And generally when we talk about diffraction, we talk about sound, okay, but this can also occur with light, okay. But the easiest way to explain this is what's happening right here. The person is around the corner from the radio, but they can still hear the radio, okay. And the reason is that the sound emitted from the radio comes up to the corner and simply turns or bends around the corner. Okay, I'm sure all of you at some time have been walking down a hallway and heard someone yell your name. Even though you couldn't see them, you could hear them, and that's because their sound actually traveled down their hallway and then bent around the corner and came to you. Okay, this is what we call diffraction. And the last type we call interference. There are two different types of interference. What happens during interference is that two or more waves start interacting with each other, and they will either build up or break down. Okay, so we have what is called constructive interference and destructive interference. We see constructive interference here, and we can look at either crest or troughs. It does not matter. I'm going to focus here on the top picture right there, and we have a red wave and a blue wave moving at each other. The blue and the red waves are of the same amplitude. They also are of the same frequency. So as you can see on the right there, when they overlap with each other, the result here is some constructive interference. And we end up with a wave that is twice as big. Okay, and by big we mean it has twice the amplitude. Okay, so during constructive interference, two waves combine and produce a wave that is greater than the two previous waves alone. Okay, this is what we call constructive interference. Okay, for this to occur, the waves must be in phase. What does that mean? They have to have the same frequency. We talked previously that frequency is a measurement that we use for waves, and has to do with wavelength and the number of waves. And as long as they have the same wavelength and we have the same number of waves, the waves are said to be in phase. As you can see there, the blue and the red one are exactly the same size. They have the same amplitude. They have the same wavelength. All of those different things. If they have the same frequency or in phase, this will result in constructive interference. Okay. And the second thing that must be true in order for there to be constructive interference is that it must be two crests or two troughs that are overlapping with each other. Okay, either two crests or two troughs that are overlapping. And if those two crests or those two waves are of the same frequency or are in phase, they will be constructive. On the opposite side of that is the destructive interference. And instead of the two waves combining to produce a larger wave, the two waves combine to produce a wave that is less than either one, or they completely cancel each other out. Okay, so if we can see in this case, we have the two different waves, the blue and the red. And when they get together at the same point along the black line, since they are of amplitude, but they are opposite each other, in other words, we have a crest overlapping with a trough, they will cancel out. Okay, or if you look at the bottom one, the blue one being twice the amplitude of the red one becomes just half. The resulting wave is half the size. Okay, so again, what two things must be true? Again, there must be a match in frequency. Okay, amplitude and wavelength must be the same. But in this case, it is a crest overlapping with a trough. Okay, if this is the case, we get destructive interference. So if we look at these two pictures and we look at these two red ones up here, they are in phase. They have the same amplitude. They have the same wavelength. Okay, they have the same frequency. The result is this blue wave. Okay, so this is what we call constructive. Now if we look at the second picture, we can see that the trough or the crest and the troughs are overlapping. In each case, there are the same amplitudes. There are the same wavelengths, the same frequencies. So what happens is these two waves completely cancel each other out. So if these were two sound waves, they would have canceled each other out and we would not hear anything. And this is called destructive. And this is the way that many things that we use, noise canceling devices, work, is they emit a sound or they emit a wave that is the opposite of the incoming wave, which cancels out and that makes it quiet or muted. Okay, so again, this is how sound canceling devices work.